Hello everyone. In this tutorial I'm going to be illustrating the interpreted aspect of time Petri nets we're using in our tool, and this is where the denomination interpreted time Petri net is coming from. So basically what we mean by interpreted is that we can add to a time Petri net, we can add variables to it of type integer, and we can modify them, check them, and update them if you want. And this adds some modeling power to the basic time Petri nets. So let's start with in the previous example. The model was about producer-consumer, and as you can see here, we have a place for the producer, place for the consumer, and the place P1 here, which played the role of a store or a buffer. And we had the controller. The controller was a place which had initially 5 tokens. Whenever we produce, we take a token, and whenever we consume, we put back the token in its place. And if we generate the state space, we get a bounded state space, as you can see here. And this is because we have this controller here. Now I'm going to be doing exactly the same thing, but instead of using a controller, which is a place, I'm going to be creating a variable, and the variable is going to be updated and checked when transitions are going to be fired. So here, to add a transition, a variable, I will add it to the model. So I will have to go to the Petri net attributes viewer. So here, when I press this button here, we can see the attributes of the whole Petri net as a whole. One of the attributes is the color. It controls the color for the background. Let me revert to the right, it's more clear. And here we can see another attribute which states that the Petri net, is it directed or not. Here it's not very relevant because Petri nets are directed. If we uncheck this one, you see it's not directed anymore, but here it doesn't make any sense. We have another attribute for parameters, and this attribute is useful when we are composing many Petri nets. If we have a project with many Petri nets and we compose them, then we're going to be using this parameter attribute, but for now we're not going to be using it. So what I'm going to do, I'm going to be creating a variable. I'm going to be calling x, and it's going to be of type number, so it could be a real number, and it is initialized to 0. We can initialize it to any value. We have just to double click inside and then change the value and press return. So I'm going to leave it like this. I will remove this place, so I don't want to control the production using this controller here, but I'm going to be using variable. So just remove this place by clicking here. Now if I leave it this way, the Petri net is not bounded. So if I try to generate state space, it's going to be infinite. So what I'm going to do in a transition, for example, the production transition, if you see here, you can see a guard, which is a condition. And this guard here is a condition for the firing of the transition. By default, it's true, which means that the transition can be fired anytime if the input places have sufficient tokens. But we can change it and put a condition on places and also on variables, the variables we have. So here I'm going to be saying that I'm going to be firing this transition if the x is less than 5. So we can add we can write a bigger condition, like if also the producer is different from 0 or whatever, we can do that. But I'm going to leave it as a simple condition here, x less than 5. And as an update, when the transition is fired, what I'm going to do, I'm going to be incrementing it. So x equals x plus 1. We can write many updates, not only one. So you have just to put semicolon and then they continue. But for now, we have just one update. This is for the production. So the production now is constrained with this condition on a variable x, and whenever we fire the condition, we do this update. I'm going to be doing a similar thing for the consumption transition. So here for the guard, it's going to stay true because we can consume whenever we have a place. It doesn't depend on x. But here, just to do proper work, I'm going to be decrementing x. So x equals minus x minus 1, just to say that we have an extra place in the buffer. And now what we can do is to generate the state space. So let's go for that. So this is the previous state space, as you can see it here. So in this state space, if we take one space, one state, if we check it, we can see the state content. It's this one here, and here you don't see the variable x. And I can of course display this attribute state for all the states by going to each one of them and checking this box here. But what I can do, I can also use an attribute controller, okay, and then I can select from the list of these attributes any one of them, and then I can apply actions on it, like viewing it or hiding it or removing it or adding whatever, and you can select on what's going to be the target for this action. So here I want to display the state for these states here, or the nodes here. So what I'm going to do is to select the attribute state, but since I don't have it here, I have just to create one. So it's going to be state, add it. It's going to be like a number or whatever. It's not important. The type is not important here, so I select it as a number. And then I will select it here. I would say view, and it applies on all the nodes. I can select on the arcs or select the nodes or not select the nodes. So for now, let's go for all the nodes, and I do that, and you can see that the attribute is showing for all of these things. You can of course move these things here if you want to. Stretch the graph if you want, just to make it clearer. So now I'm going to be removing this state space. This is my Petri net now. It's an interpreted Petri net. It contains variables, and now I'm going to be generating the state space. This is going to be state space which preserves LTL properties. Press OK, and as you can see here, this is my graph, and it's almost the same as the previous one since it's doing exactly the same thing. And here, if I go to the states and I display the states for the nodes view, okay, then I see that, and then you can see in the state the variable x, it shows with the place content. So one extra thing is the grid. If you have remarked, whenever I press on a node or select a node here, I can of course move it around. It is attracted by the cross here in the grid, the crossing of these, if you want, wires in the grid. And this is because I have a grid here which I can control, and here it's active. It says snap objects to the grid, so I can just deactivate it. I can display the grid or not, and I can modify the spacing between the grids. So if I do it this way, the grid would just disappear, and then I can move the nodes wherever I want. Okay, so that's it for this video, and thank you for watching.